Hello friends, welcome back to my channel. Now in this video I would like to introduce you another branch of mathematics, that is a numerical analysis. Friends, the basic difference in the numerical analysis is here this is a calculus of finite differences, and we are familiar with the calculus where we can study limit, continuity, derivatives. In that calculus, their independent variable changes continuously over the interval, and then we calculate the limit and derivatives of the that changes. Now we are aware with the fact that when the independent variable change, there is a change in dependent variable, and when x is a continuous, that means there is a no gap between the values of x, then we have calculated the derivatives, that is the ratio of change of two variables, the dependent variable and independent variable. But there are certain circumstances where the independent variable changes with finite jumps or with unequal values. Then that criteria, then that in change of dependent variable come under the case of calculus of finite differences. For example, if we have a function y equal to f of x, suppose that my function is y equal to f of x. Y equal to f of x is our function, and x is uh, x is an independent variable here. Y is dependent variable, and suppose there are values of the x like a plus h, a plus 2h, a plus 3h, where you can see that the difference between any two consecutive values of x is h, and h is called as a interval of differencing. Here we call it as a interval of differencing. And for these values of x, these are the values of x, and for these values of f of x, the dependent variable f of a, values of dependent variable are f of a plus h, f of a plus 2h, f of a plus 3h, like this. So you can see that these differences, the jump of dependent variable is of equal width, and the x variable here, the independent variable, we now call in the calculus of finite difference as an argument. So here, and the values of f of x, we call it as entries. So we are here introducing three things. One is a interval of differencing, and second one is independent variable, where we values of this independent variable is called as argument, and values of dependent variable are called as a entry. Now here you can see that then we can calculate the difference of these two, f of a plus h minus f of a. So these difference, then again f of a plus 2h minus f of a plus h, that is the difference between any two consecutive value of the entry, and f of a plus 3h minus f of a plus 2h, etc. So you can see that these are the differences, and these differences are from directly from the value of independent variable, and these differences are called as first differences. These are called as first differences, and for this first differences we use the symbol delta. So delta is an operator, and we denote this first difference f of a plus h minus f of a by delta f of a. Similarly, the difference of these two value we denote this by delta f of a plus h. The difference of these two values, we denote this by f of a plus 2h. So the first differences are like this: delta f of a, delta f of a plus h, delta f of a plus 2h. Now you can see that in this symbol delta f of a, the delta f of a is an operator which calculates the difference of the forward term. Forward term of the f of a is f of a plus h, and forward term of f of a plus h is f of a plus 2h. The forward term of f of a plus 2h is f of a plus 3h. So here we calculate the difference between forward term of the function of the term f of a and f of a plus h. So delta f of a is nothing but the difference of f of a and its forward term, and hence sometime we call it as a forward differencing operator. It is also known as forward differencing operator. Delta is a forward differencing operator. Friend, we are familiar with operators: derivative, limit, continuity, integration. So these are the operators. Similarly, here we are introducing here forwarding differencing operator. Forwarding differencing operator, or simply we denote it as a delta. So what is a delta? Delta is nothing but the difference of the two terms. Suppose here we take here f of a, so it gives us f of difference of f of a plus h minus f of a. The term forward term of f of a, forward term of f of a is f of a plus h, and this f of a. So delta f of a operate on f of a gives us the difference of f of a plus h minus f of a. So this is the first difference of this term. Okay, first finite difference, we call it as a first finite difference. Now easily we have here f of a. These are the first finite differences: f of a plus h, then delta f of a plus 2h, like this. These are the first finite differences, etc. When we take the difference of first finite differences, that means delta f of a plus h minus delta f of a. So this is the difference of the first finite differences, and we call it as a second finite differences, and we denote it by delta square. So here delta square is a nothing but a square of delta, but it is a repetition of delta two times. That means delta square of f of a is nothing but delta of delta f of a. Delta square of f of a, it is not a square and it is a repetition. And here how we have calculated this delta square? Delta square is nothing but a differences of first finite differences, and square to it, it means that it is a second difference. It is a second differences. These are the second differences. And how it is a repetition? So if we calculate this value, delta f of a is nothing but, here you can see that delta f of a plus h minus f of a. When we put this value here, delta f of a plus h is f of a plus 2h minus f of a plus h, and delta f of a plus h minus f of a. Okay, then you can see that here f of a plus 2h minus f of a plus h, this minus f of a plus h minus plus f of a. Hence this is f of a plus 2h minus twice f of a plus h plus f of a. So this is the delta square f of a. And how we have calculated? We have taken the difference of the first finite differences, and it is called as a second finite differences. Similarly, we take the difference of the second finite differences. So in this manner we get the second finite difference. Second finite difference we can calculate like this. The differences of the second finite differences are called as a are called as third finite differences. So let me first make some space here to introduce you regarding the first finite, second, third finite differences. So remember these things. What is here? What is mean by first finite differences? First finite differences are the difference of the two consecutive values of the function. Okay, and here let me write the second finite differences. Second finite differences are delta 2 f of a, delta 2 delta square f of a plus h, delta square f of a plus 2h, etc. These are the second finite differences. Now when we consider the difference of these two second finite differences, that is delta square f of a plus h minus delta square f of a, the difference of these second finite differences are called as a third finite differences, and we denote this by delta cube of f of a. So delta cube of f of a equal to, here you can see that we have calculated delta square f of a, that is f of a plus h minus 2 f of a plus h plus f of a. Hence delta square f of a plus h is f of a plus 3h minus twice f of a plus 2h plus f of a plus h minus delta square f of a plus h, f of a plus 2h minus twice f of a plus h and plus f of a. So if whenever we put this value f of a plus 3h and this f of a plus 2h minus f of a plus 2h, we get 3 times f of a plus 2h, f of a plus 2h, this plus and this minus minus plus, so we get 3 times f of a plus h and we have minus f of a. So here this is the third finite difference of delta f of a. So what is the third finite differences? Third finite differences are the differences of the second finite differences are called as a third finite differences. Similarly, we can define the fourth finite differences, and in general we can define the nth finite differences of f of a. And nth finite differences of f of a means n minus 1th finite difference of f of a plus h minus n minus 1th finite difference of f of a. So likewise we can calculate the number of times the differences n. These are the nth finite of differences. So friends, I hope you have get the idea of what is meant by first finite differences, second finite differences, third finite differences, and nth finite differences, and how the operator delta works, and how we calculate the difference of these two terms. And this is a new concept to you. Thank you friends, thank you for watching the video.